safety in building installation. Very fortunately, today we are having an eminent resource person with us, Mr. G. Krishnakumar. For introducing him, it will take at least 10 minutes because his profile is that much long. He's a graduate electrical engineer from National Institute of Technology and having more than 40 years of experience in projects, energy audit, safety, and so on. And he's a certified energy auditor from Bureau of Energy Efficiency, and is a licensed electrical supervisor and a chartered engineer from Indian Institute of Engineers India, and is a member of Quality Council. And during this vast 40 years of experience, he worked with various industries, including Jyoti and Reunion, and then Usha Telehoist Bharat Bijli. And he was the National General Secretary and currently the Chief Operating Officer of Society of Energy Engineers and Managers, SEAM. And currently he is working with a corporate association as a project associate. You may be interesting to know what is corporate. Some of us may be knowing what is corporate associate. It's an international organization promoting safe electricity practices, energy efficiency, and clean energy. I heartily welcome you, sir, for this webinar series on behalf of National Safety Council, Kerala chapter.
Thank you.
Welcome, sir. And hearty welcome to all participants for a wonderful learning session. And I request all the participants to keep your mic in muted condition until completing this webinar. We can post your queries and questions in the chat box, and we can discuss across during the question answer session. And at the end of the session, we can unmute and ask questions directly.
Thank you.
Over to sir, please.
Thank you, Mr. Radhakrishnan, and a warm greetings of the day. Eid Mubarak to all. It is my privilege and honor to participate in this National Safety Council's initiative of making aware the professionals about the safety of industry as well as buildings. So, to those who are not familiar with International Corporate Association, it is a non-profit, non-commercial organization. We are in the business of advocacy of electrical safety, reliability, and sustainability. And we are also working in close liaison with all the government bodies for the clean energy transition. Many of our members are in the various electrical forums like BIS, ETDs, etc., to help governments to formulate the policies, rules, codes, etc. And my name is Krishnakumar, as he has already introduced a lot of things. Okay, I am a project associate for International Corporate Association in Kerala. We do many seminars and webinars on safety of electrical installations in buildings. Definitely, this this is a statistics which you are seeing on the electrical accidents. This is CEA published data. We are among the countries having maximum number of electrical accidents. Of course, Kerala record is slightly better, given the higher educational abilities of the electrical wiremen, contractors, etc. in Kerala, as well as the awareness among our users. So, but that doesn't give us. Day before yesterday, I was listening to our Prime Minister, the Power Minister, inaugurating the Electrical Safety Week in Trivandrum, because he cited that the number of fatal accidents have come down to 111 last financial year. But that doesn't we can't take any big, we can't be very happy about that situation, because the developed countries like Sweden, etc., which to which we normally compare our life standards, etc., they are having only one or I mean nearly zero accidents, fatal accidents per year. So with our kind of people who are working with the level of intellect the people are working in this field, we can also definitely aspire for making a zero accident state at least. Okay, that can progress towards the country. I mean, that is at least we can mind our Kerala. Okay. So unfortunately, when we talk of electrical safety, we start with some gory pictures like this. Okay, that is a very sad plight which we have to resort to. This happens. Okay, many of you may be familiar with these kind of scenes. Okay, and where is the risk more? Okay, if the statistics are to be viewed, most of the electrical accidents happen at a low voltage level, that is at 440 and 230 volts, and among those accidents also the highest percentage happens in the domestic sector, residential sector. So that is where the ignorance plays a major role. That is where the onus of the electrical community, electrical engineers, right up to the wireman, have got a greater responsibility to see that installations are 100% fail-safe, accident-proof, etc. So our responsibilities become much more. Okay, I believe I am addressing a gathering of electrical engineers. That is why I am using the term we. Okay. So what are the see, mostly you learn about fire accidents in many places, and ultimately people trace it all to short circuit, etc. So we can harp on the prevention as the first method, and then where the initiation is arrested, and post initiation the spreading is arrested. So that is the kind of the preventive measures which we can take to avoid such accidents. Ultimately, many of the cases, after all those investigations also, people largely go scot-free. Very scarcely I have found people pinning the responsibility to what exactly has happened. Okay, so what are the possible causes of electrical accident or fire accident or due to electric fault, etc.? It starts with the design. If the design is faulty, definitely it can play havoc later. Then defective material. See, it may run for a few days or months, and then it can deteriorate and give all kind of nonsense. Then defective installation. So we'll dwell upon all these factors later. Okay, then testing and verification. This is a very ignored aspect of electrical installations. Of course, then leakages and short circuits can also happen in spite of all these things. Okay, so these are the causes of all accidents which are happening. Then how do we prevent? I mean, our interest is in preventing. Okay, rather than lamenting on the accidents which has happened. Then wiring installation. Okay, that planning stage itself. At the building service, and I have found that see, in many of the buildings, even high-rise buildings, electrical engineer, they don't except for big builders, they don't take the services of an electrical consultant, except for big buildings. Okay, the reputed builders, of course, they have got everything, but they also play a subservient role to the architects, and architectural drawings, they have to accord the proper space for installation of meter board or distribution boards, then ducts, etc. These gets compromised in the name of aesthetics invariably in many installations. The other day I was talking to the chief electrical inspector, sir, even the meter board and distribution board gets hidden inside under a staircase or a godforsaken place in a building. And so that shows the scant respect for electrical installation in a building, which is so vital to the safety of the people who are occupying those buildings. So unfortunately, this is happening. And then it comes to civil construction requirements, and there also compromises are made. Then there can be a inaccurate assessment of the load. Okay, initially people don't bother about when you apply for a permit for a even say single owner house or even multi-unit installations, the electrical load assessment takes a back seat. Okay, that is at that stage it is left to the imagination of an architect who go by thumb rules, etc., rather than depending on an electrical engineer or an electrical consultant, because this, unlike in the past, because as Mr. Radhakrishnan was mentioning, I passed out in 1977 from NIT Calicut. At that point of time, the load in a building or in a house was less than a kilowatt, mostly. Okay, and the scene now is vastly different. I mean, there are independent bungalows in Cochin requiring the installation of a transformer. So that is the kind of load requirements. So the assessment of load itself has gone a sea change, and sometimes people are not taking cognizance of that change and the volume magnitude of requirement of electrical load. Then there are a host of standards, codes, regulations, which, and government on their part is doing their job fantastic, and they are catching up. Of course, codes, regulations, standards do catch up with the progress of the technology, progress of the requirements, demands, etc. So, but they are doing a good job of catching up with it, and to give due credit to those agencies, they have brought out the NEC 2023 and recently, and CEA regulations also have come out in June. So these if you practice to the if you listen to those requirements and observe them in your practice, then much of the problems are taken care of. So we'll go by the how the design fault comes. Okay, when you select a cable or wire for the buildings, earlier, if somebody had asked me when in 1978, when I just passed out, somebody had asked me, how do you select a wire for a building? I would have merely told that depends on the load. Okay, load what just to cater. Absolutely. And the sad part is that even now when I ask this same question to contractors, wiremen, etc., I take classes for the wiremen across the various districts of Kerala. I ask this question as an opening remark. I ask, how do you select wire for the your building? So you got a job, you say, how are you going to select a wire? Invariably, the answer comes as depending on loads, sir. So it's a child play. And why are you asking such stupid questions? Okay. But unfortunately, the changed scenario demands that alongside load consideration, you have to consider two factors more. Okay, what are those? Because in the earlier days, I mean, I'm going back to about 40 years back in the history, there used to be, as I told, the average load in a building used to be hardly 500 watt. Okay, less than a kilowatt, and those days the transformers were used to be in a, and many of the villages, I mean, hardly a smaller percentage of houses were electrified at that point of time, and the transformers which used to serve those buildings or houses were reasonably at quite a distance, say maybe and a few kilometers away. And those capacities of those transformers are also very smaller. But,
okay. Reason for that was Gemile contract float poet fail. That is the reason. 1.5 months ago.
Somebody wants to discuss something? Hello?
Hello, Mr. Joy. Can you please mute your mic?
Okay, I'll continue. I was talking about the transformers being at quite a distance of a few kilometers from the buildings, okay, houses. So, and the capacity of the transformers also very much lower than what we now see. As a result, what used to happen is that even if there is a short circuit in your house, the short circuit current, magnitude of that short circuit current used to be very low, maybe around 1500, 2000 amperes, which we could merely rectify, or I mean disconnect through fuse wires. Okay, it is a direct acting fuse wire. So the moment electric current goes, if the fuses are right, it will disconnect, fusing the thing. But now the scene has changed. Okay, now nowadays, there are flats. I am staying in a flat. Right below the flat itself, there is a transformer of 100 kV. Okay, so that means if in my house, if there is a short circuit, that 100 kV transformer is going to pump the entire current into my wires in my house. Okay, my flat, and that current can go to the extent of even few kilo amperes, like 15, 20 kilo amperes. And what I have got to for protection is that MCBs and ELCBs. Okay, but these MCB or ELCB, they are all electromechanical devices. Okay, so first it will sense the current, over current, short circuit current, etc., and then that will they activate a mechanical device to disconnect the circuit. But there is a time lapse. Okay, that will be this MCB operation will be a vast subject for another discussion altogether. So I'll know. So there is a time gap of milliseconds. That time gap is quite good enough to heat up the copper conductors in your wires and raise the temperature beyond 100 degrees. Okay, with why 100 degrees is important is that most of the insulation, which is PVC, so the 100 degree, it will melt or catch fire at about 90 degrees centigrade. Okay, so that will play havoc. So so that short circuit current carrying capacity is a consideration to be factored in when you decide about the size of the cables, wires. Okay, now and one more factor is there. See, in the 40 years back or few decades back, the whole electrical installation in a house was merely a few bulbs, and the entire thing was you had it on the batten wiring or CTS wiring, what you see, and so it could be seen where the fault is and how, if at all there, and to have a short circuit was a very rare phenomenon because there is hardly any equipment, any gadgets here. But now the scene has changed. Even to have a light, we need a quite number of electronic components behind it. Then only we get light even. Okay, leave alone the gadgets which you use in the kitchen, the drawing room, etc. So all these are and electronics, as you know, that in spite of all the stringent quality control, etc., the components can go fut and then it can create a short circuit. So two things have happened in the comparing with the decades back installation and now is that the possibilities of a short circuit has gone up, and at the same time the magnitude of short circuit current has gone multifold. So very significantly alongside load factor, this comes as a this is to be considered as a factor. Plus, see, another factor also has come in the picture is that the I normally ask, I will not ask this crowd this question, but I ask the wiremen. See, some of them will be seniors who has practiced for years together. So I asked them the question: you had seen a bulb called 0-watt bulb in your old days, okay? How much watt they consume? Many of them, many of them tell very promise, sir, it is 15 watt. Okay, then I asked them the question: why is it then you call it a 0-watt? Many of them don't know the answers. Okay, so so I explained the mechanical device which used to read the energy and then it couldn't detect that energy. Now, now the scene has changed that we have got electronic meters reading that energy, and even see the voltage loss, the IR drop in the wires also will be measured by the electronic device. Okay, the IR drop will be much lower when the conductors are of a thicker size, higher size. So that is why the now people recommend a one size higher wires for this thing for two reasons. One, the earlier I told about the short circuit. I'll tell you, short circuit withstand capacity in say the technical experts have assessed that in order that the copper conductors go beyond 100 degree temperature within the short span of the MCB tripping time, etc. So minimum cross section has to be 1.5 square mm. Okay, but unfortunately this is not observed by our people. They feel that by using 1.5 you will be draining the pocket of a consumer. So as if doing a great favor to the consumer, they use a instead of 1.5, which is recommended, which is insisted, which is stipulated by the IS code, NEC, and other regulations, they go jolly well. Advise the, as a very seasoned wireman, they will always advise the consumer. Then, sir, now we have got only LEDs, so why you want to have very thicker wire? It can very low current will flow through this, and any customer will be happy to have a little saving a few rupees, but this land them in great trouble and the due course, because see, as you all know, the smaller the cross section, resistance will be higher and it will be heating up more than the thicker wires, and the constant heating and cooling of the conductors will deteriorate the PVC insulation, the dielectric strength of the insulation which is there, and this will gradually lead to a deterioration in the insulation quality, and ultimately they give in. So that used to happen. And the electrical insulation, which is supposed to render you fault-free service for about at least 25-30 years, this is see, it doesn't give you that kind of a long service, and it will give in very easily at the early date and causing fires, accidents, etc. So this is one principle which largely get ignored, is called derating. You have to derate the wires because many times the cable sizes, what they proclaim in their the catalogs, it can't carry even 50% of the capacity, because see what they show in their brochures is when a conductor is in the naked condition and it is in the free air, and when the current is flowing through it, how much current it can take without heating it up extraordinarily. But the factual or actual situation is completely different. Neither the wires are naked, nor it is free in the air, because we enclose it in conduits, and the alongside we have other wires parallelly running, and those conduits we embed in the walls for the sake of aesthetics. Okay, this and there is no way this heat generated in the wire can dissipate. Okay, so it is absolutely necessary to derate the wires. If a 1.5 square ohm wire is rated for say 13-14 amperes, you should not load it more than 7 amperes ideally. So that is the kind of derating. So because you will be able to understand this derating and all, but see, when I talk to the wireman, I tell that okay, you just blindly, if you calculated with the load and factors, you take the next step of wire. If you found that 1.5 is the current cross section by your calculation, take 2.5 instead. Okay, somewhere it is 2.5, go to 4. Okay, so like that, the higher rate, or in other words, you are derating the wires and using it. This is one principle which will save lot of troubles in a building. Okay, especially so yeah, some people will argue that will become very costly and all. No, so but see, in a see 2000 square feet house, or see, likewise, I ask this, I gather the information, I estimate it as an additional cost of less than 10,000 rupees. For a 2000 square feet house in Kerala now, which will be costing a minimum of 60 lakhs, and it will be housing not many equipment, gadgets, etc. to the equal worth, and 5 or 6 lives. Even as an insurance premium, 10,000 doesn't merit any major consideration. And this is and if this is projected correctly to the house owner, prospective house owner, he will jolly well shell out that 10,000 rupees without any problem. Without any problem. Okay, so only he needs a little bit prompting. And out of my experience, I am 100% sure that, because there is stiff resistance from our wireman community, contractor community, that no, the people, the owners will be very finicky about the cost involved and all. I see, I allay their fears, because I have got live examples that many customers after this. There are instances when the wiremen give my number after having talked to these people, prospective client. So they get in touch with me, and I explain the same, whatever I told you just now. I explain them, and they are very receptive to such ideas. And now now I understood why 1.5 is the minimum wire required, and why I should go for a higher thickness wires in this thing, and they are jolly well listening to that. Okay. So that is one area. Our probably you can spread this message that minimum cross section which is to be used in the one wiring, house wiring, fixed wiring, is 1.5 square mm wire. That's very important. And in spite of the load, so these are the two factors which you have to consider. short circuit withstand capacity as well as the voltage drop in the current, in the voltage drop or I squared R loss. I mean, you can either way put it. Okay, so these two things can be taken into account. Okay. Then of course, in the wire selection, we always recommend that you go for the branded wires. Okay, because they invest their manpower, energy, time, cost, etc., to see that their reputation is not in danger, because they see that the wires go out of their factories tested and will conform to the standards, IS standards. And why I'm insisting on this, because there are smart chaps who will advocate for why you are buying this very costly branded wires. There can be one, because the copper is such a metal which can be easily converted to wires. Okay, and every household in India, it is estimated that around 5 kg of copper exists in almost all the households in the form of vessels, ornaments, then winding, art materials, etc. Okay, so decorate materials, etc. So there are people who will get this copper, and it can be easily converted to wires. The same is with the this PVC, which also get recycled. So if it is not virgin, if it is not ETP copper or virgin PVC, it will all land up in problem. Say there can be hot spots as far as the conductor is concerned, and there can be weak spots as far as the PVC is concerned. And if by any chance, if they coincide, the havoc is certain. Okay, so these are some, because it can be eliminated by resorting to top brands who will care for their name. They will ensure that the wires coming out of their factories are foolproof and it's conforming to the standards, etc. Then of selection of see, there are, if in the case of a house, the fire hazard, because in the high-rise buildings and where the crowd is expected, like prayer halls, high-rise buildings, hotels, hospitals, cinema halls, etc., you have to go for this FR-less cable, which will emit less of a smoke. This has become mandatory after the fire incident in Upahar way back in 1978 or 9. There there was a transformer burst accident, and then quite a few number of persons had to meet with the destiny. And see, there the cause of the deaths was the stamping of people. People in hell, they were running helter skelter, and they couldn't see their way. Okay, because of the smoke screen. The smoke was so heavy, thick, and dark, and that led to the people stamping against each other, and quite a few deaths happened. So thereafter, it has become mandatory that in the wherever this crowd is expected, you should use the FR-less cables. In addition, now there is another, see, now especially in the high-rise buildings, there is a requirement of keeping the integrity of the circuit intact, even in the case of a fire, to the extent of at least about three hours, when the evacuation can take place. Okay, essentially those installations will mean that we have to cater to the lift, the fire lift, then fire quenching, let's say fire pump, which your what you call the indicators which come, no, showing you the way out, and all those those things have to be lit always. Emergency lights have to be kept intact. These things have to be kept alive, even in the case of a fire, at least for a duration of 3 hours. and they use fire survival cables. Almost all the major brands have got these fire survival cables. They have to be used in the high-rise buildings, and especially all these sensitive areas like hospitals, high-rise buildings, then metros, airports. All these places have to use this fire survival cables as well. Of course, this is very no-brainer that the color codes have to be very, very religiously followed, so that your RYB and the wrong usage of this color codes will land you in trouble, or the electrician who is going to rectify something, he'll be in trouble. Okay. So that is the how you select wires after the design. In the design stage, you have to assess the load clearly, correctly, assess the load requirements of a house or a building. Then you have to select wires according to the various factors which I explained. Now coming to the electrical installation part of it. Installation part, there are ample number of codes. Okay. Where the role of an electrical contractor who will be translating the consultant's drawing to shop drawings. Okay, that the skill and competence of the electrical contractor has to combat with the requirements in such a way that he has to understand what is the electrical consultant may at best give a single line drawing, but the shop drawing, the laying out of the wires to the extent, those have to be done by the electrical contractor who at the ground is going to install, to implement those things. He has to be conversant with the latest standards in the. See, there are many, especially IS 732 will be the Bible for any wiring installation. That has to be strictly followed. That is, and other standards are also. Incidentally, all the standards now, these are now made freely available. You can download from the BIS site, and it is ready for use for any public. Okay. And even NBC also, National Building Code also advocates that this even see up to 16 square mm you have to use only copper, so that that these are okay. Largely they assume it up to 6 square mm it is strictly followed, but beyond 6 I have seen many installations aluminum being used, but that is strictly not advised by the NBC also. And circuit integrity I discussed, because MSI light lifts firefighting system has to be taken care, and that is by way of using a fire survival cable which can survive the fire for about 3 hours, 180 minutes perhaps. And if you go to the highlights of the 732, see now, earlier now, see in the hierarchy of this rules, codes, etc. If I can explain, if it is a triangle, the pinnacle of it will be the act, or the electricity act will be at the top of the apex of this. See, see that is something which is to be observed. Then comes the rules or regulations. For any act will be a very short description of what is required. Okay, it cannot at length describe the nitty-gritties. So they form the there are government bodies who will, the act will be passed by the parliament and the respective legislative assemblies. Then there will be regulatory authorities who will bring out regulations and rules, okay, which will on ground level how to implement those acts. So now That is one which I referred to earlier. CE has brought out two regulations of 2023, which has given a lot of teeth to the act. Okay, now they say that observing the standards and codes have become mandatory. You can't escape it, and there are punitive measures if you don't adhere to those standards and codes. Okay, earlier it was only on a guidance note, but now it has become mandatory, and it is this can land the operators, the contractors in trouble once the things get more scrutinized. Okay, and it is going to happen very soon. Okay. So these are some of the size of conductor and its protection is well defined in the IS 732, selection of cables, etc. Then current, see the things which I explained a little while ago. So all those things are highlighted in the 732. Sorry. And electrical installation, the verification also, the low voltage installations. That is, if I use a common language, whatever is inside your house will never be checked by anyone. Okay, hope you all agree with me. Those who are experienced, you get a contractor to sign, he'll give the permit requirement, and that is the contractor himself will be the installer, he will be the inspector, he will be the verifier for the in-house the installation inside. No third party inspection is hardly done, but that scenario is going to change soon. There are already Central Electricity Authority has mandated that there has to be inspection of the low voltage side installations inside the buildings also. And the earlier the claim was, or the argument was, that there are insufficient workforce to with the electrical inspectorate to do so. So now they are trying to create a cadre of chartered electrical safety engineers after their test and interview, etc. They will be designating chartered electrical safety engineers who will be authorized to inspect household installations after once in every 5 years, so that they it is rendered, your installations are rendered trouble-free, accident-free. So a lot of regulatory measures are being taken, and only we engineers, we have to take on our responsibility to explain this to our customers. Okay. See, on our part, we conducted some tests on the cables. Okay, see, building electrical installation, cables are also an integral part of that. Apart from the wires which we discussed so far. So this we saw that whenever this I told up to 16 square mm, this aluminum cables should not be used, because we made some thermographic studies where we found that the aluminum cables, when they are terminated over a period of time, the secure nature or tightness of the terminations get loose, because they have got the coefficient of expansion is different. So it becomes and that loose contact will lead to heating up, and that creates undue heating up, and then overheating, oxidization, and then result in fires. Okay, this has happened. This is a table of fire safe cable, where all it has to be used. I mentioned about the fire safe cable, fire pumps, pressurization pumps, smoke venting, firefighting, stair, and then fire lift, exit signages, okay, emergency lighting, fire alarm. So all these places you need to have fire safety. Medical locations or hospitals, in common language, they need additional this thing, because especially because see in the case of a fire incident in a hospital, in other places, no, the people are say free to move. Okay, but in a hospital there will be patients who are confined to bed. See, no way they can run to safety on their own. So there the standards are little more stringent, and so now see this IS 17512 stipulates the electrical installations in medical locations. I mean, and see there even the smallest spark can create a havoc, because the hospitals are a oxygen rich atmosphere. Okay, now, unlike other places where you all know that in our atmosphere oxygen is present to the extent of 20%, and here in hospital is a place where it exceeds, it will be in the range of 25%. Okay, so it is a very conducive for catching fire. I mean, so it has to be, you have to be extra careful in the medical situation. Another, in the house wiring, people ignore most is the earthing. In an industrial situation, the scene is different. The industrial engineers are trained, and whenever they get some electrical installation done, they ensure that earthing is done properly, and they measure the values, and the proper earthing is done. But unfortunately, in the case of buildings or house wiring, it is left to the imagination of the electrical contractor or a wireman, so they are. I have seen some cases where the earth wire inside all they put bare earth wire, bare copper wire, run it all around, and then come and terminate it on a GI plate. Again, it is all in the name of saving money for the customer. Unfortunately, he is put to trouble. Okay, in a place like Cochin, the GI plates or GI pipes, you won't see, it will vanish within about 3-4 years. You will be left wondering where the earthing was. Okay, and another thing is that, see, if there is two different metals are used for the earthing, what happens is that there is a phenomena called galvanic corrosion. So when the electricity passes through two different conductors, this corrosion happens, and that is what you see in a GI earthing. You will see a white powder at the termination of the GI, and that white powder is an oxide of iron, which is not at all a conductor. And the whole purpose of earthing is defeated, because earthing protects by way of the residual current principle. RCDs are used for protecting. So, so when it will sense the heavy rush of current, and then it will act, and that is how you are protected. But in spite of having a ELCB and then this earthing by way of copper wire and terminated on a GI, because of this white powder, galvanic corrosion, white powder business, see that current is restricted, and your sensing device will not sense that over current, and it will not trip, and the faulty situation will remain. Okay, so you will wonder, in spite of having all the earthing, etc., still the person who was using that the equipment which has got a earth fault has got a shock. Okay, or even leave alone, I mean, it will end up in a disastrous thing. And see, these things can be avoided by using the same metal, preferably because copper has got more resistivity towards the atmospheric deterioration. It can last at least about 15-20 years if proper plate or this even the sufficiently coated copper tubes are used. That will be then earthing. You need to keep this thing. And now increasingly the importance of verification and testing is coming to the fore, because see, it's important that there should be a second opinion, because in all other cases, you know, we all, even if when you have got a headache also, you will go to one doctor and take a second opinion. But only in the case of electrical installation, your wireman is your friend, philosopher and guide, and you end up with that. Okay, you don't take a second opinion, but it's always better to have a verification. Okay, and even in high-rise buildings or major installation, this is not a practice, but in other see, in advanced countries, it is already existing. Third-party inspections and verification of the installations is a practice, and in some cities like Bombay and all, it has started, and there are third-party inspectors who will verify after the installation, so that no, you see, and in this, that is for a new building. Okay. In addition, see, I mentioned about the chartered electrical safety engineers. This is a cadre being created. They will be required to inspect the low voltage side also, that is the inside your home, which is now beyond, because the chief electrical inspector, they have defined a safe voltage level. I mean, there is a stipulated voltage level of 650 volt, above which only they will be inspecting. Okay, so industries are by and large safe because they have got a higher voltage requirement. So there, these inspectors will be coming, and and there is an annual inspection procedure there. But unfortunately, in the building sector, there was no provision of such periodic inspection, which now, because of the CESC rules, once it get implemented, this inside house wiring also will take a place, and then the anomalies can be brought forward to the notice of the owner, and the remedial measures can take place. Okay, so let us hope that with these, so in this stakeholder ladder, there are many. All these people are there: promoter, builder, and owner. He gives the work to the architect. Architect in turn may act as the MEP consultant and electrical consultant, or he may contract. Then there is an electrical contractor. Then there are utility who will be supplying your, and regulatory authorities and the user. I mean, these are the hierarchy of the stakeholders. See, each of these stakeholder has got a responsibility. Okay, one cannot escape that this thing. And Central Electric Authority now has very categorically stated that if any violation, inconsistency can result, I mean, it is mandatory. Okay, it is a punishable offense. Okay, and see, especially the Electricity Act 146, punishment for non-compliance of orders. Or so here, even the earlier the observing the standards and codes was only a guidance part of it, but now it has become the latest guidance, latest regulations by the CEA tells that it is mandatory to observe. Okay, so any contravention of this standards or codes will attract punishment and imprisonment. It can be imprisonment up to 3 months with a fine. Okay, all those things. Okay, that is. I mean, I'm not trying to be negative about it, but say, we are all law-abiding citizens, you know. So unfortunately, some kind of a stick is also required to see that even if we don't put on our helmet also with full satisfaction. No, only because we are fearing that policeman and his challan, then only we are putting the seat belt or a helmet. Okay, so some kind of a stick is also required, and that teeth has been lent to the act and regulations now. Okay, so when a offense is committed by a company, every person responsible in charge. So for the industry engineers, this will be very, very important. I mean, if you get a request or instruction, be careful. Okay, if you do it, you can be proceeded against by law. Okay, so the rules are becoming stricter, stringent, and any violation can result you in trouble. Okay, so protect yourself by resorting to the right practices, be aware of the standards, codes, etc., and do the best thing, and that will see any accident, fire or otherwise, or fatal, etc. These are all resulting in pulling our country back. Okay, and in our progress towards a better GDP, better amenities for all our people, etc. This will be a drag on our economy as well. So it's all the more responsible as a citizens and technical personnel. We all should work towards observing the rules, encouraging people to observe the rules, advocating, etc. So that our country can also match, our state at least can also match with the standards set by Sweden, Norway, etc., where I'm told that the rate of accidents is as low as 0. Okay, so we can also achieve, at least Kerala, I'm very confident that with the kind of people, infrastructure we have got, the progressive outlook of the electrical wireman community as well as the user community, we can work towards that with if we all pull our force together. Okay, so remedial measures of a certificate of compliance, which we on our part as a copper association, we are trying the architectural planning requirement that the recent NEC also elaborates on architectural planning requirements, how decks have to be planned, spaces have to be provided, all those things. Then civil work requirements, all the compliance. So this certificate of compliance can be issued by the person concerned, because the architect, when he gives a certificate of compliance, before he signs, he has to think twice, because if any adverse observation at a later date can land him in trouble, him or her. Okay, same way, who has done the civil work. Then electrical work, for a license, it has to be given to a licensed electrical contractor, and he has to give a proper certificate. And because there, I don't know how many of you are aware of the new regulatory authority, real estate regulatory authority has been established. They mandate that a builder or a developer has to be responsible for any quality issues as well. Alongside contractual obligations, he has to be responsible for the quality issues for 5 years even after handing over. So in that space, if any accidents occur, there will be a lot of inspection, investigations into who did it, where the fault was and all. So then the certificates of compliance, certificates of the conformity to the standards, and this will, by the various agencies, will come to their rescue. Okay, if at all, if they have done the right jobs. Otherwise, they will be taken to task by the authorities, because all these authorities are getting more and more teeth. Okay, this RERA is a recent phenomenon, maybe a 5-year phenomena. Okay, so things are getting stricter. So it's a part of when we as a country is progressing, this openness, transparency has to be a part of our progress. So it will be the order of the day sooner than later. Okay, then declaration of the design compliances. Once the electrical consultant or a contractor, he has to give a declaration. Then declaration in respect of installation work, who has done the installation wiring the per se in the exact the way it has been laid out, and declaration in respect of the testing and verification. I mentioned about the testing in the first phase and first place, when the initial handing over, and then periodic inspection afterwards by the CESCs. And checking now, see, the invariably I asked the electrical contractor during my seminars, etc., how many of them keep the handing over documents. Because I insist, I take a pledge from them that they'll now onwards they'll have a layout drawing, that is shop drawing document, then finally earth testing document. They'll record the measurements, and then alongside they'll hand it over to the owner. So see, those people, see, at least for their conscience can be clear. I have done a good job. I have seen that my client is saved from troubles, from accidents for a quite number of years. That will be ensured. And apparently, in case of an investigation, see, all accidents need not be traced to this. It can happen out of blue also. Okay, so in that case, he will be saved if these documents are all intact. So, and by and large, if all these documents are or documents or the philosophy behind those documents are adhered to, then we can might as well. I mean, the number of fatal accidents in Kerala, it is in the domestic installations, it is coming to around 111. That is what last day Power Minister was telling. So that can come down to very low figure. Okay. So and when I signed up with the Copper Association about in the year 2014-15 or so, I went to Chief Electrical Inspector at that time. It was from the statistics, he told that about 190 domestic accidents had been reported the previous year, and 165 were fatal, human fatalities. Okay. So that was one impetus that I took up with a lot of passion to reach out to the electricians to tell whatever I know and I can gather to improve their competencies, so that even if one life can be saved, that would be a great achievement. That is, with that mission only, I started taking up this mission, this initiative of Copper Association. I at least about 4,000 wiremen, contractors would have attended during last 5-6 years of my association with the Copper Association. And see, fortunately, I mean, from 165, it has come down to 100 level, which is by God's grace, and with the efforts of Electrical Inspectorate and many other, and with the cooperation of, and many wiremen listened to this my discourse very clear, and they have come back to me with their compliance reports, and they are telling that, see, now sir, when I talk to customers, they also listen, they also appreciate. Okay. So that's a good sign. I mean, so with the help of NSC and all, Copper Association can build up this momentum, build on this momentum, and still render our state the way we all wish to be, a accident-free place. Okay. So to summarize, the electrical work, an important building service without which building cannot be complete. I mean, it's a no-brainer. Defects concern the lives of innocent people, where survival rate, because in other building crumbling down also, there are chances that people can get survived. Okay, so they may survive, but in the case of an electrical accident, the survival rate is very, very remote. Okay, fire accidents is alarming. The statistics of fire, because India is credited to be about 300 fire deaths in a year, which is among the highest in the countries, okay, in the world. Consumer is totally ignorant, and that should not be exploited to fleece out money from him and then pass on substandard insulation, substandard material to him. Okay, because consumer ignorant in sense he is ignorant about the electrical nuances. Okay, so and promoters depend on appointed agencies because they don't know, because as a developer he may engage an architect, he may engage an electrical contractor, and they have to do a right job. Okay, so this so I told the hierarchy of all the stakeholders how each stakeholder has its own role to play in alleviating the improving the situation, and streamlining the responsibilities possible with certification and declaration procedure. On our part, Copper Association is relentlessly working with the government authorities to establish this kind of a regime, certification and declaration procedure regime, so that people are aware, people are more conforming to the regulations and rendering the world a better place to live in. With that, I stop here. Thank you very much for patient listening. I am open to questions, which I can answer. Okay.
Thank you, sir. Hello.
Yeah.
Okay. It was a very wonderful session. You start from actually it was a very deep and broad eye-opening session. You start with the fundamentals of selecting cables, why it should be derated, why there should be some allowance, and why should not we go for economics when we selecting the cables and the gadgets, and even the fundamentals of galvanic corrosion and acts, rules, regulation, and the Police Act. Now the things have become serious, and the consumers have to be careful. And when we are going violating the rules, now it become very mandate and it's compulsory to follow the rules, regulation, and standards. Everything is up. So very wonderful session. Now the forum is open for the question. No questions in the chat box. The participants can unmute and ask questions. Please.
Yeah. So questions teach me a lot. So I welcome.
Okay.
Many questions I may not be able to answer, but then I am required to find answers for myself. That is the beauty of question answer session.
Some discussion will happen.
Yeah.
The participants are requested. Please.
Yes.
Can you please introduce yourself and answer the questions?
Good afternoon, sir. Hello.
Yes.
Yeah, we can hear
Good
you.
afternoon, sir. Sir, this is Neeraj.
Yes.
Okay, Neeraj, please ask.
Sir, actually, I just need to know about the earthing part a little bit more.
Which part?
If
Earthing,
sir,
okay.
Regarding safety, human safety.
Yes.
Sir, actually, some of the OEM give a value of earthing for their machine that is required for installation. Okay. And most of the time in IT sector and hospitals, they just ask a grounding value less than 1. Actually, we just measure that value on the pit. That can be that easily can be measured. Now, when the earthing, then protective conductor comes to the machine, bring to the machine, then how may we check that value? We just do one thing. We just check the value between earth and neutral. That a voltage we check.
Voltage level you check.
We check. Yes, sir. And they just need that voltage less than 1 volt or 1 volt.
Yes.
Sir, which standard state this methodology, and is it correct to check it, or there is some other methods available which are more authentic than this?
Now, see, IS 732 describes how the earthing is to be done. See, earlier, you could see just like somebody is planting plantains, the earth pits are dug out around the building. Okay, that is not advised now. It is advised that you should have one earth pit. Okay, all the other conductors, all the earthing conductors have to be brought to one earthing terminal, and one earth pit has to be there, where you should get a sufficiently close as as to the equipotential with the neutral. Okay, that is to be ensured. So there it is a challenge. Okay, in our congested construction sites, etc. But then you can have an additional this thing, deeper plate, deeper pit, etc. And to ensure that at that point the zero potential is ensured. Okay, if that is done and with the proper conductor, proper earthing conductor of the right size to the various equipments, you can ensure this close to 1 volt. I mean, so that is being achieved. Okay, you can look up at that 732 standard. You can download it, and that clearly, now the latest one, 2019 one, that clearly states how you have to have the earthing. And another stipulation this 732 gives is that even the supply agency also have to give you a earth terminal, which unfortunately it is not being practiced. Even see, electricity board also, your service wire, it has got only phase and neutral, no?
Yes, sir.
So that also will change. Now they will have to give a earth wire as well from their what you call them, when from their transformer earthing. So then that will solve to a great extent, because there will be a metal continuity till to the transformer earthing, transformer neutral. So things will move towards, I mean, once the standard gets enforced by engineers like you, CESCs, etc.
Okay. Thank you, sir. Thank you very much.
You can look up that standard.
Neeraj, this was the same question open from yesterday. Yesterday also you
Yes,
had
sir,
the same question.
Actually, I asked the same question, but I didn't find that answer in IS 3043. So
no, it is not in the, it is in IS 732.
Yeah. That
yes,
is
yes. Now I'll do it.
Look up.
You're right, sir. I repeated. Sorry, I think you will not mind it, but I am not clear from that answer. So I just repeat my question again.
There are so many discourses on earthing. I mean, so yesterday also, the day before yesterday, I was also privy to listen to one, because every day you learn more about it. I mean, the concept of earthing is undergoing a change from the past. Okay, the way.
Honestly speaking, sir, it is very confusing subject for me, and actually, I always have a confusion on this.
Yeah, seemingly very simple, but it is posing higher and higher intricacies now. Okay, the more you delve, the more you will say you are in the right path. If you are getting confused, you are in the right path. I can assure you that.
Thank you, sir. Thank you.
The famous dictum is that once you are confused, you are exploring more.
Thank you, sir.
Thank you, Neeraj.
Thank you, sir.
Any more questions?
Neeraj, where are you working?
Sir, I am working in Jaguar, sir. Sir, I think you didn't recognize me. We actually, I was in touch with you from last 2-3 years. Actually, I was just preparing for energy managers. Actually, from BE.
Oh, I see. Wonderful. Very good.
You also blessed us in that session, sir.
Okay. Yeah, okay. So this time also we are launching another exam preparation session. Probably.
Yes, sir.
I don't know. Yeah.
Now I am an energy manager, sir.
Oh, great.
Certified energy manager.
Congrats.
It was all your blessings, sir.
No, it's your effort. Okay.
Thank you, sir.
You can look up at its website also. That will also give a lot of information. copperindia.org. Radhakrishnan sir, any more questions?
No more questions come in the chat box. The participants can ask the questions, please.
Sir, if you allow me, may I ask one more question?
Definitely.
Oh, yes. Yeah, that will be beneficial because everybody is
Sir,
not
actually,
very. Tell me.
Which I think is we found that is much safer side. If it's a chemical earthing or it's a once we make a pit and just do the earthing.
I've heard both
plate
the
earthing or pipe earthing basically.
Plate earthing with the traditional method is also equally effective. See, I have seen advocates of both. Okay, this chemical earthing is of a off-late phenomena. See, over a period of about 20-25 years only, you can validate something like that. Okay, that is yet to be done. Okay.
Okay.
So it will get validated over a period of, I mean, maybe in another few years, we'll have a concrete confirmation of that, which is better.
Okay. Thank you, sir.
If no more question is there, shall we conclude it, sir?
Yeah.
Okay.
I'll be happy.
Okay. Thank you very much for this enlightening session. Thank you once again for this your time and effort put with us, and thank you for all for this participation.
Yeah, so we on my part from International Copper Association, we look forward to more closer ties with NSC, and I request you to join our efforts to make the policy changes, rule changes, etc. in the state, so that we can make this our state electrical accident free.
Yes, even one life saved can be it will be a great effort.
Yes. That will be worth our time, and that is
yes.
my.
Definitely, we should work associate.
I look forward to more initiatives.
Thank you, sir.
Working
okay,
together.
Thank you.
So I can sign off.
You.
Sure. Thank you.
Okay, bye.